Good morning all. Here we have a Payne Engineering heater control, and this is the control board. And to increase and decrease the output to the heater elements, we have 4 to 20 millivolts into this terminal board right here. Now, in order to input that 4 to 20 milliamps, I made this homemade current source, and it will output a current so that we can test this control board and this SCR diode bank. Now, we have plus 15 volts ground and minus 15 volts on these three terminals right here, and the current output is on these jacks right here. So let's hook it up and we'll test this Payne Engineering heater element control. And at the end of the video, I'll put up the drawings of this box right here, and you can make one for yourself. It'll be a good addition to your toolbox. This is the power supply we're going to use to make the plus and minus 15 that powers up the current source circuit. Here's our plus and minus 15 connections. Here's our current source connections. There's those right there. These are fluke meter set to milliamp mode. And this will monitor the current from our current source into that Payne Engineering control board. Set those down there. Turn the light on. This position so you can see it. I'll read the milliamp measurement to you if you can't see that. But we'll get a little bit closer here in just a little bit, and you'll see when I adjust that potentiometer on the current source that these values will increase and decrease. I'm using the three-phase light bulb bank as the load to simulate the heater elements. I'm applying 460 volts AC three-phase to L1, L2, and L3. The light bulb bank is connected to T1, T2, and T3 down here. Okay, I'm adjusting the potentiometer on the current source circuit. Set my meter to DC. There we go. There we go. There's 5.05 milliamps, 6.23 milliamps, 7.68 milliamps. The light bulbs are turning on. There's 8.9, 9.02 milliamps. There's 10.3, 11.16 milliamps. The light bulbs are getting very bright. There's 12.67 milliamps, 13.09, 14.09 milliamps. 16.07 milliamps. We're almost at 20 milliamps. 19.8, there's 20.04 milliamps. And those light bulbs are very bright. I'm going to use my amp clamp and test the AC current on T1, T2, and T3. Okay, on T3 we have 1.49 amps. T2 we have 1.49 amps. T1 we have 1.51 amps. That is fairly well balanced right there. Now if one of them was unbalanced, we'd have to find out why. Say for instance we had 0.5 amps here, 0.5 amps here, 0.5 amps on T3, 0.5 amps on T2, but we had 1.5 amps on T1. We'd have to find out why we're not balanced, why the current's not balanced. All right, let's reduce our current to that control board. All right, the light bulbs are getting dimmer. There's 7 milliamps, and I don't see no light illuminated from those light bulbs. There's 0.09 milliamps. Okay, let me move the camera and you can see the intensity of the light bulbs when we increase that current. Okay, here we go. There's 4 milliamps, 5, 6 milliamps, 7.13 milliamps, 8.22 milliamps. There's our light bulbs that come on. 9.28 milliamps, 10.22 milliamps, 12 milliamps. Oh, they're bright, aren't they? 16.6 milliamps, 17 milliamps, 18, 19.5, there's 20 milliamps. I'm going to have to add in 2 more light bulbs right there. All right, let's decrease the current output of our current source going into that control board. I'm going to rapidly increase and decrease that current. That circuit is working. Okay, let me power down. We have other things to do too. We have an amazing weekend here. I got the IGBT in for the Graspy Controls inverter drive, and there's an oscilloscope here in the shop that I need to work on. Channel 2 stopped working. Channel 1, the voltage and waveforms are displayed properly, but channel 2 it's flatlined. So we're going to have to go in and find out what's wrong with that oscilloscope. Not sure which I'm going to do first. The inverter drive or the oscilloscope? Okay, we'll see when I get over to the bench. Okay, removing 460 volts AC 3-phase from the Payne Engineering heater control. Let's turn off the plus or minus 15 volt power supply. Set our meter back to voltage mode. I do that after every current measurement because if you measure a voltage while it's in current mode, you'll pop that fuse and possibly blow up your meter. So always set your meter back to voltage mode when you get done measuring current. Let's move this out of the way. you go. If you can, go out and make you one of those. That's an amazing little circuit. I'll put the drawings up of the schematics, and you can make one for yourself. Be a great addition to your toolbox. I need to get a knob. It'd be a lot easier to turn that if I had a knob. All right, on to the next job.